Have you ever watched a rocket launch and seen parts of it just fall off? It looks a bit strange, right? Like a car shutting its doors as it drives down the highway. But this isn't a design flaw. It's actually one of the most brilliant ideas in the history of spaceflight. This is rocket staging. And without it, we'd probably never have reached the moon, sent rovers to Mars, or put satellites into orbit. Let's break it down. The biggest enemy of any rocket is weight. To get into space, you need to achieve an incredible amount of speed, something called orbital velocity. For Earth, that's about 17,500 miles per hour, or 28,000 kilometers per hour. To get going that fast, you need a tremendous amount of thrust, which means you need powerful engines and a whole lot of fuel. But here's the catch. The fuel itself is incredibly heavy. In fact, for most rockets, about 90% of their total weight is just propellant. This creates a vicious cycle known as the tyranny of the rocket equation. The more weight you have, the more fuel you need to lift it. But the more fuel you add, the more weight you have, which means you need even more fuel to lift that extra fuel. It's a frustrating problem that early rocket scientists wrestled with for decades. If you tried to build a single, giant rocket to go all the way from the launch pad to orbit, it would have to be astronomically huge, impossibly heavy, and would require so much fuel that it couldn't even lift its own weight off the ground. It just doesn't work. This is where the genius of staging comes in. Instead of one massive rocket, you build several smaller rockets, or stages, and stack them on top of each other. The first stage is the biggest and most powerful. Its only job is to lift the entire rocket off the ground and push it through the thickest part of the atmosphere. It's packed with a huge amount of fuel, and once that fuel is used up, the first stage becomes dead weight. It's just a collection of empty tanks and heavy engines. So, what do you do with all that useless weight? You drop it. By jettisoning the first stage, the rocket instantly becomes much, much lighter. Now, the second stage, which is a smaller, more efficient rocket, ignites its engine. Because it's starting its journey already high up and moving fast, and because it has far less mass to push, its engine can be much more effective at accelerating the remaining part of the rocket. Think of it like a relay race. The first runner gives it their all for the first leg of the race, and then passes the baton to a fresh runner. The rocket's first stage is that first runner. Once it's exhausted, it passes the mission over to the second stage. This process can be repeated. Many rockets have 2 or 3 stages. The famous Saturn V rocket that took astronauts to the moon had 3 main stages. Each stage would fire, do its job, and then be discarded, making the remaining rocket lighter and faster. The first stage got it off the ground. The second stage pushed it into Earth orbit, and the third stage fired to send the Apollo spacecraft on its way to the moon. Each stage is also optimized for the part of the journey it's designed for. The first stage engines are built to provide massive thrust at sea level, where the air pressure is high. The engines on the upper stages, however, are different. Making it not only necessary for getting to space, but also much more affordable. So, the next time you see a rocket launch and watch that first stage separate, you'll know you're not seeing a malfunction. You're watching a clever and absolutely essential solution to one of the biggest challenges in physics. It's the reason we can explore the cosmos, by shedding weight along the way. It's a perfect example of how sometimes. I hope this helped you understand the why behind those spectacular launch sequences. It's a fundamental concept that made spaceflight possible. If you enjoyed this video and want to learn more about the science and engineering behind space exploration, and see you in the next one.